Hello, welcome to this lesson. In this lesson, we're going to be talking about constructing confidence intervals for proportions. This is going to be the main goal of the lesson. In this lesson, we're also going to practice how to interpret a confidence interval using the context of the situation. That has been a learning objective that we have been carrying out throughout this chapter. It is really important for you to recognize what the confidence interval represents. Now, before we try to construct confidence intervals for proportions, it is really important for you to recognize that you do know how to calculate proportions. This is something that we did when we were talking about probabilities. Here I have a warm-up to help you recall how we calculate proportions. Assume that there are 10,000 individuals in the population and 4,000 said they support a new law. Can you find the proportion of individuals that support the new law? And can you find the proportion of individuals that do not support the new law? Let's start with part A. We're going to let P be the proportion of individuals that support the new law. This proportion is equal to the number of people that said they support the new law, which is 4,000, divided by the total number of people in the population, which is 10,000. This is equal to 0.4. Notice, we simply took the number of people that support the new law divided by the number of people in the population. This is just like finding theoretical probabilities, which is something that we did in a previous chapter. Now, can you find the proportion of individuals that do not support the new law? Let's use Q for this proportion. There's different ways of finding Q. Think about it. Q, the proportion of individuals that do not support the new law, is the complement of P. To calculate Q, we could take 1 minus P, 1 minus 0.4. Okay? So that's one way of doing it. Another method would be to simply think about how many people do not support the new law. We would take that value and then we would divide by the total number of people in the population, which is 10,000. So how many people do not support the new law? Well, think about it. If 4,000 people said they do support the new law and we have a total of 10,000 people, then that means that 6,000 do not support the new law. Okay? So Q is equal to 6,000 divided by 10,000, which is 0.6. Notice again, Q is the same as 1 minus 0.4, which is 0.6. Q is simply the complement of P. Again, the only reason I included this warm-up is to show you that you do know how to calculate proportions. Okay? So now, let's go ahead and talk about a point estimate. We talked about how X bar is a point estimate of mu. That means the sample mean is a point estimate of the population mean. Now in this lesson, we're talking about a point estimate for a proportion coming from the population. A parameter often estimated is a population proportion, and this is denoted as P. Again, P represents a proportion coming from the population. As I have mentioned before, in most cases, it's impossible to study the whole population, so we have point estimates to help us estimate parameters from the population. A point estimate of the population proportion would be a sample proportion, a proportion coming from a sample. The sample proportion is denoted as P hat. Here it's really important for us not to get confused between the sample proportion and the population proportion, and that is why we're using different symbols. We're using P hat for the sample proportion. We are using P for the population proportion. Okay? Now, if you're wanting to calculate the sample proportion, you can do so by taking X divided by N. Here, X is the number of success and N is the sample size. Now, to help you practice finding a sample proportion, I have the exercise here below. We're going to read the problem together and then you're going to be finding P hat on your own. So we have an undergraduate researcher who's interested in knowing the proportion of American adults who speak 2 or more languages. He conducted a survey with 565 randomly selected American adults, and he found that 226 speak 2 or more languages. Your goal is to find the sample proportion of American adults who speak 2 or more languages. In other words, you need to find P hat. Now let's think about the given information. Your sample size is 565. That is the value of N. N is equal to 565. Now, you're also being told that 226 individuals in the sample speak 2 or more languages. This is the value of x. X is 226. With this information, you should be able to find p hat.